Nginx is the company behind the popular open source project trusted by more than 450 million sites. They offer a suite of technologies for developing and delivering modern applications. The Nginx application platform allows enterprises to modernize legacy, monolithic applications as well as deliver new, microservices-based applications. Check out infoq.link/Nginx for more information.
Welcome to the InfoQ podcast. My name is Wes Rice and I'm your host. The InfoQ podcast is produced by infoq.com. InfoQ is a site for senior software developers, architects, and technical influencers. You can find news and feature articles on innovator, early adopter, and early majority trends in software. InfoQ is also the sponsor of QCon, which I have the privilege to chair. QCon is an immersive 5-day technical software conference where leaders in software meet to discuss their work and learn from each other. Hope you can join us in an upcoming conference. This week, I'm talking to Simon Brown. Simon is well known for his work on training architects and the practices and processes of architecture. On today's podcast, we discuss things like the difference between a tech lead and an architect and what he sees in the wild. We talk about how much documentation is enough documentation for software systems, and we focus on things like what does that look like in a CI/CD environment, for example, along with some of his observations on working with hundreds of software teams around the world talking about architecture. Thank you for joining us on today's InfoQ podcast. Welcome to the InfoQ podcast.
Thank you.
So I most well know your work because it focuses not just on what is software architecture, but also on the role of a software architect. Why is it important to focus on both architecture and the role of an architect?
It's important because I think as an industry, we seem to have lost track of how to do architecture well, especially with modern agile teams, if you like. And if you go back to 2001, when the whole agile thing came about, I think a lot of teams saw the agile movement and they almost threw away a lot of the ceremony and the process. And of course, included that with some of the architecture stuff. So the stuff I talk about mostly revolves around lightweight practices for doing architecture. So that's the toolings and the techniques, but also the role of architectural and modern agile software teams. And I find it's really hard to teach one without the other. That's the simple reason, I guess.
You talk about agile. In a lot of classic agile contexts, there's a lot of folks not necessarily thinking there's a need for an architect at all, that everybody's an architect. What are your thoughts in that space?
I have this discussion a lot with people, especially when they come from the more extreme end of the agile spectrum, should we say.
It's a religion, right?
Yeah. And again, if you go back to 2001, the whole agile thing came about. Before that, we had this very traditional hierarchical approach to architecture, where there was, normally one person on the team pretty much dictating what to do. And agile came along, and it was all about self-organizing teams and emphasizing trust. And a lot of teams over the years have told me that we are doing agile in quotes, and therefore we don't need an architect because we're all architects. And that can work with some teams. So I have seen some good examples of teams where they have, small, really experienced development team. There's no dedicated architect, but between the team members, they have the collective experience and knowledge to do the architecture role well. On the other hand, of course, I've seen probably a lot more teams where you've got the typical mix of experience and knowledge and, different personalities on the team. Everybody's not always agreeing, for example. And on those sorts of teams, you do often need someone to take the technical lead role. And in essence, for me, the software architecture role is the technical lead role.
Do you think it's a function of culture or technical aptitude?
Both. I've traveled to about 30 countries over the past few years. And I've worked with different teams in those countries. And some of the teams in some of the countries have a very, very different culture to other teams in other countries, for example. A couple of examples, when you tend to go into sort of North Europe, so Scandinavia, Norway, Sweden, Denmark, those teams tend to have much more of a kind of self-organizing style culture. Whereas if you go further west, especially the UK, for example, sometimes you don't quite get the same sort of feel. And some of the teams tend to be a bit more hierarchical. So yeah, there's definitely a culture thing here, but of course, technical experience and knowledge does matter.
Let's back up a bit. How does Simon Brown define architecture today? And how does Simon Brown define the role of an architect?
Let's start with architecture first. For me, architecture is basically about two things. It's about structure and vision. So you're building a piece of software, you need to be able to understand how to describe and visualize that software. So look inside your software, what's it made up of? So there's a structural element there, building blocks, modules, components, relationships between them. So that's a very kind of static view of the world. But we also need to take a set of business requirements, a wish list, and translate that into some notion of an architecture, some notion of a software design. So there's the whole design process there. And one of the things that Grady Booch says a lot is that architecture represents the significant decisions where significance is measured by cost of change. And that's another crucial part here. For me, architecture is about the significant decisions, the things that are expensive or costly to change later.
So you mentioned Grady Booch. That's how I grew up with thinking about representing architecture with UML, particularly in an environment where it's constantly changing. What's the right way today to represent the architecture?
I'm still not sure there is a right way. But having said that, I have seen lots of wrong ways. And one of the things I do a lot is I fly around the world and I run a one-day workshop where I help people visualize architectures. And it's broken up into two iterations. The first iteration in the morning is basically, here's a set of requirements, go away in teams of 3-4 people for an hour and a half, design a solution, and then draw some pictures to somehow describe your solution. Now, I think about 10,000 people have done this around the world, and I've seen every single type of architecture diagram you can possibly imagine, and even some you can't possibly imagine. And I think that just goes to show you how little consistency there is in the world of describing, visualizing, documenting architectures. So I also grew up in the UML era. So a lot of my projects that I worked on when I was living in London, we used UML for documenting a lot of that stuff. And again, you can almost point to the early 2000s, just after the agile thing came around, and people started kind of dropping UML for some reason. Again, baby in bathwater moment, maybe it was just a generational thing, who knows. But I'm seeing lots and lots of teams now not use UML, and instead they're just using horrible ad hoc diagrams that don't make any sense. So that's like the current state of play, if you will, which is terrifying, isn't it?
I still use UML when I'm representing something on a whiteboard because I feel like it's the vocabulary. It helps you communicate an intent. It helps you represent a design pattern. I use it for that, but for actually documenting the architecture, it changes too much to using UML, at least in my limited experience with it.
So I also use UML, but I only tend to use UML for the stuff where I want some precision and detail. So if I do want to document stuff at the class level, for example, UML suits that beautifully. But you're right, you do have to be careful because that stuff does become out of date very, very quickly because you're basically mirroring the code, aren't you, in a diagrammatic form.
What do you use to represent one level up? So I used to, in particular, use a lot of UCDs to be able to represent use cases and boundaries of systems and actors that are interacting with it. What do you use at that next level up?
I've created something which I call my C4 model, and it's a super simple hierarchical way to think about a software system in terms of the structures that make up that software system. This is kind of easier if you have a set of slides to walk through, but very briefly, if you imagine a software system, for me, that thing is made up of what I call containers. A container is something like an application or a data store, so a mobile app, a web app, a database, for example. If you look inside those containers, for me, they contain components. A component is just a grouping of related functionality behind a nice, clean, simple interface. And because I mostly deal with Java and C#, my components are built from classes. So that's it. It's just a simple 4-layer structure to describe the static structure of a software system. So now I can answer your question. What I do is I step up one level from the classes to show components. And that's a grouping of classes that make up some piece of functionality generally.
Let's talk about that. So you said context, containers, components, and class. When you're talking about the context level, what again is the focus of the context?
With the set of abstractions in mind, what I then do is I draw a set of diagrams at each level in turn separately. So I'll start off with a very, very simple system context diagram. And this is basically, drawing a box to represent the system I'm building in the middle of that diagram. And then around the edges of that box, I'll draw the people and the other software systems that my system interacts with. So it's basically just a really high-level map, essentially, of users and systems.
Okay, so that's what I used to use, at least for UCDs, to be able to define all the boxes inside there, right?
Right, yeah. And I've seen a lot of people do that as well. They have the little actors pointing into the bubbles, and then they draw the boxes around the bubbles to somehow represent the system boundary.
And then you said a container is like a web container or some grouping of a service or functionality?
Yeah, so the easiest way to think about this is that it's a deployable thing. So it's something you can deploy separately. That's mostly how we use the term container. So something like a standalone Java application would be a container. Something like a Java EE web application, that would be a container. A database schema, because you can take that and pop it on different databases, that's a container. A folder on a file system, a mobile app. So that's what I mean by a container. It's basically like an app or a data store, something separately deployable.
In today's microservice explosion that we have, no pun intended, what does that look like?
So in a microservices world, a container would typically be the microservice and maybe the data store that it's using, of course.
There would just be many of it. What about the horizontal instances? Is that represented as just a single box, or is it represented as layered boxes?
What I tend to do is I try to keep the static view of a system separate from the deployment view, because you might have different deployment views for different environments, for example. So my static diagram will just show a single instance of everything talking to one another. And then I'll have a separate deployment view, much like the UML deployment view, for example, that shows you how those containers are mapped onto pieces of infrastructure, be those physical servers, virtual servers, Docker containers, whatever they are.
Using the C4 model that you just described, how do you document things like security or maybe risks? How do you look at threat modeling, those kind of questions?
There are a couple of ways to do this. Most of the time, I will just use supplementary documentation, which sounds very boring, but that's just the easiest way to do it. With things like risks and threat modeling, I have a little technique I call risk storming, which I teach people. Basically, what risk storming is you draw some pictures of the thing you've built or the thing you're about to build, the thing you want to assess risks on. You get as many people as you can who might have some interest or knowledge of that system. So developers, testers, ops people, business analysts, domain experts, whatever. And you give them some sticky notes of different colors. And what you say is, for the next 10 or 15 minutes, as a little time box exercise, look at the diagrams and identify what you personally perceive to be the risks with that architecture. And of course, the risks could be anything from data breaches to things failing, falling over, that sort of stuff. And then when you've identified a risk, you have some sort of priority scale, like likelihood versus consequences. So you rank your risks. You take colored sticky notes, so you have different colored sticky notes for high risks, medium risks, low risks. You write on the sticky notes, you keep them to themselves, so it's like an individual exercise. And then step 3, when the time box is finished, you ask everyone to go and put their sticky notes onto the diagrams. And this is like a game storming, innovation games style thing, and it's a great way to get a different perspective on the risks associated with a particular software system. So that's how I might do risk modeling, threat modeling, that sort of thing.
You were talking about Agile a little while ago. Let's loop back to that in this context. So Agile Manifesto talked about we prefer working systems over comprehensive documentation. Of course, you know that. What's enough documentation? And again, particularly in the context of a CI/CD environment where we're continually deploying and changing that architecture, that evolving evolutionary architecture.
Teams often tell me that the code is the only documentation you need, and that's flat out untrue. So that's the one thing I do want to say straight off the bat. The code can't tell you everything. There's much more of a story that's happening beyond the code. So the code can't tell you why and the rationales behind the key important decisions, for example. So in terms of how much documentation do you do, I would typically have something like an architecture document. Whether you call it an architecture document is entirely up to you because, just that name has a certain stigma associated with it. But what I would tend to do is basically document the stuff you can't get from the code. So I want some information about context. I want some information about the architectural drivers, the things that influence the design you came up with. So the key quality attributes, the key constraints of the environment, the key architecture principles, all that sort of stuff. I want some high-level maps and information about the architecture itself. So this is where my C4 diagrams come into play. And I also want some information about how do you operate, support, maintain, deploy this thing. So that's really what I'm aiming for, is a kind of minimal set of documentation.
In an environment where you have multiple teams, we'll say Scrum teams, and they're all deploying multiple times a day, small units of working code into a production environment through a full deployment pipeline, how do you build a process where all these teams are updating this documentation?
Would these be Scrum teams working on the same code base, or are we talking, microservices and each team is pushing out something separate?
Both. How would you handle either situation? Basically, what I'm trying to get to is in the work that I've done, I built the big wars and the big ears, and I've deployed those it had 10, 15 services in the ear. But in today's environment, we're deploying not these big bangs anymore. We're deploying small units independent of each other. I just wonder how you keep documents and architecture diagrams, which I kind of have gone back and forth. I've been on the camp of the code as the documentation, and I've been on the camp of no, as the architect, we need to define this. But I'm struggling with, in this continuous deployment environment, how you keep things up to date.
Right. It's a multifaceted answer. For me anyway, it kind of depends on what sort of organizational structure you have. So if we take the kind of simpler example first, so the simpler example is we have a bunch of teams, they're all building and working on the same code base, and we're deploying multiple versions of that single code base every day. What I would urge teams to do in that case is to create one set of documentation that describes the architecture. Ideally have that checked into the source code as well. And then it becomes more of a process thing. So if you have a definition of done before you release your thing, you add another line at the bottom of your definition of done that says, have you updated the diagrams and documentation given the change you're just about to make to the code base? And then all of the changes become really small deltas. With a kind of more complex, more distributed microservices architecture, I would kind of recommend as a starting point that each team has their own set of documentation related to their own microservice. That's fine, of course, but what you end up doing is lacking that top level view of how everything fits together. So maybe you want to do that in combination somehow. So in essence, there's a lot here just about process and just about enforcing good process and saying, look, guys, have you updated your documentation whenever you do the release? The other thing you can do, of course, is throw tooling at the problem.
So you also have a tool that helps you represent the C4 model called Structurizer, right?
Yes, that's right. I teach people the C4 model and we use paper. And it really, really irritates people because now what they're doing is they're drawing lots of boxes and lots of lines and also lots of text. So one of the things I'm a big fan of is on architecture diagrams. If you look at most architecture diagrams, they are just named boxes. And that's why a lot of them just don't make any sense. So what I get people to do is to write more text in the boxes. So things like responsibilities, what does this box do, for example? And people really love the C4 approach, but they really, really hate using paper. And of course, the obvious question at the end of my workshops is, well, this is great. What tooling do you recommend? And up until about 3 or 4 years ago, I was basically, and I hate to say this, I was basically recommending Visio. Because all these diagrams are just boxes and lines. There's nothing complex here at all. And this kind of irked me a bit. So over the past few years, I've been creating some tooling. Tooling is called Structurizer. It's a tool of two halves. So there is a set of open source libraries for Java and C# currently. And the open source libraries essentially allow you to describe architecture using code. That might sound like a crazy idea. If you've seen things like Plant UML, where you create UML diagrams with text, if you've seen things like architecture description languages, where you write text to describe the static structures, it's the same concept. You're just writing some code. There are a bunch of classes in the libraries representing people, software systems, containers, components. So all you're doing is you're creating an object graph in memory to describe your architecture. So that's the open source part. There are some built-in exporters to various formats like Graphiz and Plant UML.
You write code to actually create the model that you're doing, not generating the model from code.
That's right, yeah. So you're writing some code to create a model of your software system. There's no forward engineering here, so this is not like model-driven architecture. One of the benefits of using code to create a model of your architecture is executable. If you're creating a model using Java code, you can use Java's reflection mechanism to go and find things in a real code base, for example. So you can explicitly define some stuff and then reverse engineer things from a real life production code base.
At least until Jigsaw gets you.
No, Jigsaw helps.
Reflection across modules didn't cause you any issues?
Not yet, but one of the things, and this is kind of going off topic, one of the things Jigsaw should give us, of course, is better modularity in our Java apps, which will mean in turn that architecture diagrams are easy to draw.
Because of the dependencies and transitive dependencies are all minimized a lot, and cloud deployments are much smaller because you're not deploying hundreds of jars into your service that just needs to be able to take and receive a REST response.
Right. In theory, it should be much cleaner.
I'm sorry, I went off on a tangent there.
No, it's fine. So the open source libraries are one half of Structurizer. The other half is a web-based software as a service thing. So there's a bunch of free and commercial plans. And essentially, it allows you to render web-based diagrams and also create documentation in Markdown or ASCII doc. It's like a publishing platform for your architecture model, essentially. And you can hook all that up with your build process. So this goes back to one of your other questions. that you asked about CD and CI environments. So one of the things I do is I hook up this structurized documentation stuff to the build pipeline. And then every time you push a release, your documentation gets up to date automatically.
That's wonderful. Yeah, wonderful.
There are some caveats, of course.
Yeah, there always are, right? But even being able to represent simple lines and boxes with code is easier for me in a lot of cases. That I like that a lot. I haven't used it, unfortunately, but I'll have to take a look. I want to loop back for a minute to something you said earlier. I'm sure it's one of these things where the answer is it depends, but I'd still like to explore it just a bit more. You said in essence the technical lead role is the architect. What do you see in practice as the difference between these two roles?
This is another one of those questions that varies depending on the audience. Whenever I ask my customers this question, a lot of them say there's no difference. So for them, a tech lead is an architect. And for others, a tech lead is a kind of lower version of an architect in the organizational structure, for example. From my perspective, I tend to treat them as synonymous. And if you look at Patrick Qua, he wrote a book recently talking with tech leads. And he's essentially talking about what I call the software architecture role, but he's calling it the tech lead role. And one of the nice things that Patrick does is somewhere in the start of the book, he said his definition of a tech lead is somebody who is leading a team from a technical perspective, but also writes code for more than 30% of his or her time. And I think that's a nice way to put it. So it's a hands-on coding software architecture.
Should architects code?
Ideally, yes. There are a lot of benefits for having architects that are hands-on in the production code base because you're getting feedback about your designs and your work. You're getting to feel the pain. You can see what other people are following your architectural principles. You can easily check for the quality attributes being satisfied and all that sort of stuff. On the flip side, of course, if you have a really big system that you're building and you've got lots of team members, the amount of time you're going to have for coding is diminished quite quickly. So that's why I say ideally yes. And it's an ideally yes in the production code base. But if you really don't have time to do that, then at least be engaged in the code base, do the quality reviews and the peer reviews and the design reviews and that sort of thing, really.
I always try to think of it of trying to develop a ceremony around, I will do this amount of coding between this point of the day, or not Fridays, but I develop some artificial ceremony to make sure that I don't have to think about that I will be coding at this particular time.
Yeah.
On this journey from junior developer up through architect, as you're transitioning and all of a sudden adopting this mantle of architect, when I became an architect, I didn't have a book. I didn't have, the steps that I needed to follow. What are some of the things that change as you become an architect from a tech lead that you should really focus on?
I also didn't have the book when I moved into my first architecture role, and you certainly learn from your mistakes. But of course, we do have books. I guess one of my simplest pieces of advice is to go and find a mentor. So go and find somebody who's done this role before, either ideally in the same organization that you work for, or go and find a local meetup because you can chat to other people who've gone through the same sort of experiences. The major change from my perspective, and again, you'll see this mirrored in Patrick's book, is that it's about dealing with people. So although the architecture role, the tech lead role is inherently a technical leadership role, and you have to make technical decisions, of course, you do also have to influence and lead people. You have to make sure that you have a shared vision that everybody is going in the same direction. And actually that's hard because nobody prepares you for doing that. Sure, there are consulting courses you can go on and books you can read and all that sort of stuff, but actually day-to-day dealing with people is a whole different ballgame.
I remember in one particular environment that I was in as an architect, I had no problem when I described an architecture, fired a tracer bullet, did a slice, whatever you want to call it. I had no problem getting those adopted and getting people on board. Went to a different organization. It was a startup. And it was tooth and nail fighting. I remember trying to describe a coarse-grained, fine-grained microservices, and it was just tooth and nail getting people to understand or even consider what I was talking about, which is almost standard in a lot of cases today. How do you refine those soft skills?
Practice, just by actually doing it and winning some battles and losing others. There are some books you can read and some techniques you can pick up. So I mentioned game storming and innovation games earlier. So if you're ever in the situation where you need to kind of get consensus or you want to do some brainstorming, there are some really good little techniques in those books for doing stuff in a group, doing stuff visually as well. So that, having some visual collaborative techniques can go a long way to reducing a number of the barriers associated with conflict resolution and agreement and consensus building and stuff.
Do you have one or two techniques you might recommend that somebody might consider and look at?
Techniques from what perspective?
For conflict resolution, for building consensus, for just trying to win friends and influence people.
So I'd say the Game Storming and Innovation Games books should definitely be on the list. There's lots of little techniques. You can kind of pick them up very, very quickly. But also some of the change and influence books, Switch by Dan and Chip Heath. Switch is really just a book about change and influencing people, stuff like that.
So what are some of the most interesting architectural patterns that you're seeing predominantly today?
I'm seeing things like the distributed monolith.
Yes.
I know I kind of say that jokingly, but I visited a bunch of customers recently and they've kind of proudly told me that they're now adopting microservices, but they're starting to run into issues already with their microservices journeys. And that's because what they're basically doing is they're taking the monoliths and they're literally just breaking it up and sticking network calls and REST interfaces between things. And that just doesn't scale, of course. And it is kind of worrying that I am seeing this more and more happening at the moment. I had someone email me recently and said, we're going down the microservices route and we're going to have a few hundred microservices. How do we document it? And my initial thought was, forget documenting it. Why are you going to have a few hundred microservices? Do you really need a few hundred microservices? Is there a genuine reason for this, or are you just following the industry hype? Yeah, that's what I'm seeing a lot of at the moment.
When you say a distributed monolith, can you put some context around that, kind of paint that picture for me, minus the whiteboard that should be in front of us at the moment?
Yeah. With a monolith, you put all of your components into a single deployable unit and you deploy it in one go. And if you want to modify one component, you have to redeploy the whole thing. A distributed monolith is essentially the same thing. So you have a bunch of, let's call them microservices with synchronous REST interfaces. And of course, every time you make a change to one of those services, you probably have to redeploy everything else. So you've got coupling and lockstep in terms of integration, deployments, and all sorts of other stuff.
Sounds good. I noticed on your site, Coding the Architecture, it says that you'll give copies of your book to anybody that's doing a software architecture meetup. Why'd you start doing that?
I started doing it for a couple of reasons. First of all, I don't really understand why architecture is not talked about more widely. So whenever you go to even architecture conferences, you'll see there's actually very little about architecture, the practices and processes, and it's more about the latest and greatest microservices and React frameworks and stuff. And that kind of irritates me because software architecture is one of the fundamental things that all software developers should know about. And it just kind of bugs me that we don't talk about it enough. So as a way to try and encourage meetups and groups of people to talk about architecture, both in terms of the role and the processes and the practices and techniques, I thought, yeah, I can give some books away. Why not?
If somebody wants to take you up on that offer, what do they need to do?
Just email me. So email me with details of the meetup. The meetup should ideally be architecture related. So either about the role or the process or diagramming, and then I'll throw some copies of my book.
Well, Simon, I think we're at the end point. I just wanted to thank you for taking the time to chat with us. And if you're interested in taking Simon up on his offer for getting access to his book, ping him at his email address and he can take care of you. Simon, thanks again.
You're welcome. Thank you very much for having me.
If you've been enjoying this podcast, it would really help us out if you could take a few minutes to rate us and review us on iTunes or on SoundCloud where we host this podcast. Your reviews will help others discover us. Our growth has been absolutely incredible over the last few months, and we'd like to continue to bring this podcast to more and more engineers and software leaders. Thanks again for joining us, and be sure to share your favorite episodes with your team and your network at large. Thanks.